Alrighty, howdy hackers, how's it going? Hello. Hope y'all are doing great. Hi, hello, hi. It's history time indeed. It's gonna be a fun stream. I'm very excited. Hello. All right, awesome. Let me give everyone a minute or two to get started, get popped in here. And we'll talk a little bit about hi. Howdy. Love it. Sweet. We've got, let me see. I've got some of my things already set. Hi. Hello. Awesome. I do actually. It's a pretty busy day, but in a good way. I'm excited. I have not had I've been kind of taking some time off recently, mostly because I just graduated. So it's been an exciting time, been busy, but it's been good. So hello. Awesome. So generally what we're going to do here is, first off, let me go ahead and drop the check-in link really quickly. So if you're looking to join me here, make sure you get your points and all that. You can go ahead and do that right at this check-in link here. I'm going to leave it up here for a second. We're going to do Q&A at the end of the stream. And we'll just have that running through that right down there. And then I made some slides, friends. Exciting. I love a good Google slide. My personal favorite. So we'll go ahead and jump in. If it's got any typos, I'm sorry. It's taken me a while to get it working, but I worked hard on it, and I'm excited to get to talk to y'all a little bit about Web3 history, what Web3 actually is and means and stuff. So I think it'll be a really fun stream. It's going to be mostly me talking at you for a little bit. But we're going to have plenty of time for Q&A at the end. We'll talk a lot about different parts of all of these fun and very important technologies. We're mostly going to be focusing on blockchain because that's what I'm happen to be the most familiar with, but we'll talk a little bit more about all of the other fun stuff. Hello, everybody. And yeah, so let's hop right in if we can't. I have a general plan for today. It's not a super set in stone plan, but it's here just in case anyone is curious. So we're going to be talking about kind of 4 key things today. Oh, I cut off. Oh no. All right, we're going to hope that it's working. But yeah, we're hoping for the best. Let me speak a little bit slower maybe. Maybe that'll help. I tend to talk pretty fast. But generally, today we're going to be talking about 4 different things related to the world of Web3 and Web3 history as a whole. The first one's going to be the evolution, where the word Web3 really comes from, what it actually means to be Web3. We'll talk a little bit about Web 1.0 and Web 2.0 as well, because that's where Web 3.0 really came from, the differences between those 3, and talk a little bit about anything in between there. We also are going to talk a lot about blockchain. I have a whole section dedicated to blockchain entirely. And it's going to be an introduction to blockchain as a whole, terminology, and working through any of those issues. I think that'll be really helpful, especially because blockchain tends to be what we tend to focus the most on as hackers. And we'll talk about it from both kind of a financial perspective and a historical perspective, but also from a more technical, like programming perspective, which is not something that I feel like you delve into very often, especially on the history side of things. Then we'll talk about the finance, kind of the role of business and economics in shaping Web3 and shaping how it functions. I think this is a really fun one. This is where we get into a lot more of the, I'd say, kind of more nitty-gritty parts of Web3. And also some of the newer parts, whether it's NFTs or dApps or anything and everything between those lines. We'll get to talk a little bit about those words as well. And then finally, we're going to do some takeaways So what you should get from actually attending this presentation, listen to me ramble for like an hour, maybe even longer, probably longer, and lots of time for questions at the end. So that's kind of the general plan of action for today. It's going to be a fun one. Let's go and hop into the next one here. So a little bit about me. The text is so small. Actually, it's all right. Sweet. So a little bit about me. Hi. If you haven't met before, my name's Kari. I'm a coach here at Major League Hacking, also known as MLH. And outside of all of the fun things that you see me do at Global Hack Weeks, as well as at various hackathons, my like pre-hackathon background comes from studying economics and computer science. So kind of the best of both worlds when talking about stuff like this. So that's kind of the lens with which I'm going to approach talk about this stuff. I just graduated, which is very fun. So I'm officially decreed to have known at least some of these things. And I actually took an entire class on the economics of information communication technology. So effectively, it was, long story short, the economics of Web3 and all of these things. And yeah. Oh, looks like we have a fun question in the chat here. There are so many events. How come? How can we know what the events are related to us? I've registered for Web3. Absolutely. The best way to do that is going to be going to globalhackweek.mlh.io. That's ghw.mlh.io. And there's actually a schedule straight on this website. So I'm going to post the link to Global Hack Week schedule. And this updates every month with all of the information. So every month we get a chance to focus on a different topic. For this month, we're delving all into Web3. The best part of Global Hack Week is you can kind of come to as many or as little events as you have the time. And you can always watch them back on Twitch and on our YouTube. So that's kind of the realm in that regard of all of the fun and exciting things. So hopefully that answers your question. We'll actually just also open it up to Q&A at the end of the stream. We'll also have a chance to talk a little bit about Web3 from an economics perspective. Sweet. I will get to chat all about this throughout the whole stream. I think it's definitely a very interesting kind of dilemma and an interesting dichotomy right now. It's kind of as any fledgling new technology, got some weird things that we got to work out, but definitely has the potential to really make headwaves, and it has in a lot of instances. I missed some previous streams. Are there recordings? Absolutely. You can find them on the MLH YouTube, which I will pull up a link to right now. The MLH YouTube. And then we also post all the streams live, but you can see pretty much all of them there, going way back when. So we've got tons of different helpful live streams. They're all recorded. So you can see all of those fun things straight on the lives, which is awesome. Yeah. So let me go ahead and hop into the evolution of Web3. And specifically, what I first wanted to start off the stream with is talking about where Web3 as a terminology really comes from. And I had no idea this was kind of the idea behind the word Web3 until I really got a chance to research it a bit further. And the reason why we refer to Web3 week and we refer to all of these things where we focus on Web3 technologies as Web3 is because there was actually a Web 1.0 and a Web 2.0, a Web 1 or a Web 2. Now you might be asking, okay, so what's the difference between Web 1, Web 2, or Web 3? And I've got all the answers for you. Well, not all of them, but at least some of them here. So Web 1.0 refers to what we call the static web. And the static web is what you can think of as like the first ages of the World Wide Web or the internet, as we call it, right? So way back when, when we first came up with the ideas and the concepts of the internet, they were limited to specific sort of computers that could interact with each other, right? So I don't know how many of y'all are familiar with the start of the internet as a whole, but it was actually started on college campuses, right? At universities all around the United States. They wanted to communicate with each other. I think the first web server was set up between Stanford and Cal Berkeley over in California. So these universities wanted to share things with each other, create an academic database for sharing things like research papers, journals, their findings, studies, and things like that. And we're also, kind of at the realm of beginning computing and technology as we know it. So and that is how the internet came about as a whole. But what we know as the internet, or the World Wide Web, the WWW, if you will, is the like things that really came about in the very, very early ages of the internet in the early 90s. So this was mostly, the opportunity to read some things, static pages, things that weren't really flashing, changing, really weren't interactive. It was more so information and the ability to read that information and share that information with others in some way offline. So pointing them to a resource or a journal or a website with your resume or photos of your cat. Even that is a little bit more complicated. And we'll see that when we get into Web 2.0. But it's mostly sharing information was the main goal of the static web, or Web 1.0, kind of that beginner web. So some of our key players from Web 1.0 times are things like AOL and Yahoo. These are even late 1.0 web, honestly. Our earlier ones can be things like those academic journals that we've mentioned in passing earlier. So this age of Web 1.0 is defined kind of by these like blobs of information being thrown at your screen. Then we have Web 2.0, which we know as the social web. So this is the web that chances are you interact the most with, mostly because, well, it's the one that's the most prevalent, at least in the way that we tend to talk about web. And so this is defined as read and write, and primarily user generated. It's why kind of the influx of social media as we know it is very important. So yeah, definitely very, very cool and important stuff there. 4 characteristics. This is read and write and user generated. So it includes everything like Facebook, YouTube, Wikipedia, Twitch, even TikTok to a lesser extent, although now that is very, very, we don't necessarily think of the social web as something that is new anymore. But there was a time where social web was very, very prevalent, and we kind of see that shift in between Web 1.0 and Web 2.0 in things like Gmail, right, and email as a whole. Generally, those are very, very, interesting kind of dichotomies in that regard. So it's Facebook and YouTube and Wikipedia. This is kind of the .com boom is interesting. I saw someone mentioning that really quickly. So generally, for .com booms, one of the things that was the most interesting is it's simply really the idea that a lot of companies and a lot of people thought the web was the next big thing, and they were right in a lot of ways. But what ended up happening is that there was so much money and time and investment and energy poured into all of these new companies with all of these new and creative ideas that it just kind of all imploded when they realized that, yes, some of these ideas are solvent and relevant and helpful and are going to positively impact everything and are going to cause an amazing time, and we're all going to learn so many new things, but most of them aren't that great. And so what we now refer to as the dot-com boom or the dot-com bubble or the dot-com bubble bursting is effectively just the idea that everyone was so excited about all these cool new things that could come out from Web 2 and Web 1 that they overinvested their time and energy and resources into technology, and it all just kind of imploded. Whether you believe that's going to happen again or not is not a discussion for me to have, but it's something that you should keep in mind as you learn a little bit about technology and the world and all of these fun things. But it's definitely important to kind of know all of these things as you know them. So good aside on the dot-com boom. Thank you for mentioning that. And thank you to everyone who's dropping fun references and things like building out the web server at CERN. Very cool stuff. So let's transition into what we are really here to talk about, and that's Web 3.0 or Web 3 as we know it. And this refers to the decentralized web. So if you compare Web 1, which was read-only, to Web 2, which is read and write, Web 3 is read, write, own. And so what that means is that it effectively refers to the idea that you have a higher degree of ownership on things that are related to Web 3. Specifically, you own and have the ability to own without, a third party kind of meddling in your business as much, the things that you work with in Web 3 realm. So, if we're posting things on Twitch, we are bound by Twitch's guidelines. If we're posting things on Wikipedia, we're bound by Wikipedia's guidelines, of course. That being said, the idea behind Web3 is that you have that higher degree of ownership. While we, to a certain extent, own the comments and the things and the videos that we post on Twitch, they also have a certain degree of ownership to it, right? So they have the rights and the ability to remove our accounts. We have the ability to authenticate or unauthenticate with them. And then definitely it is decentralized, which effectively is a fancy, big, important word for saying there is not one person who owns the entire thing, right? So on a Twitch live stream or on a YouTube video, YouTube/Twitch technically own the platform on which we are posting these things, right? And it's a great platform for disseminating information. It's a great way for us to interact with you and get to hang out with you. That being said, it's not necessarily the one all be all, right? If Twitch and YouTube didn't exist, we wouldn't necessarily have a platform in the same way that we have it. If Discord didn't exist, we wouldn't necessarily have a platform in the same way that we have it, right? Even if, for example, things are kind of owned by different bits and pieces in lots of different ways. And there's technically one key big owner usually over a lot of things. So the Web3 attempts to kind of change/revolutionize that by kind of taking the power away from kind of big key players and attempting to put it into things like that. Yeah, 1.0 read, 2.0 write, 3.0 own. Simple, easy, to the point. I love it. You're probably familiar with some of the examples of Web3. So these are things like blockchains, dApps, defis, NFTs, all of these big and important words that I'm going to get into their definitions way on later because we've got 2 whole hours to be talking about this stuff. So did want to drop an example here too to kind of talk about it. And we've got someone talking a little bit here about increased security in Web3, kind of teasing my next slide here. We've got potential benefits of Web3. And I think the big 3 key ones that people tend to agree on is control, privacy, and security. So control means you have a higher degree of kind of effect, kind of higher degree of ownership on what happens on Web3 platforms because you tend to own a larger portion of it. On something like YouTube or on something like Twitch or even on something like static websites and academic journals, you don't really have control over what they're doing because they, at the end of the day, do retain a large portion of the power as corporations. Whereas in Web3, whenever you import in information, you have a higher degree of ownership in that regard. So that's kind of the big key difference between Web 1.0, 2.0, and 3.0. Then we also have the idea of privacy, and that is that users can limit access to some of their information and maintain their more anonymity when interacting with Web3 technologies. This is for a variety of very fun technical reasons, largely because you don't really need to authenticate with a central player in the same way that you need to authenticate with a lot of different ways. As an example, right? Every time you make an account online, any way, shape, or form, you're pretty much at this point required to put in your email. Like, I don't remember the last time I've been able to make an account online where I have not had to include my email or my phone number or both. And in that regard, that is information that is very easily tied to you, right? My email is my first name and my last name. My phone number is directly tied, at least in the US, our phone numbers have area codes. It is directly tied to the physical area I reside in. Even just those two identifying pieces of information, you can find out, well, my name, so where I've lived, what schools I've graduated from, where I currently work, what I do in my free time, all of these very like key and important things, just based off those like few identifying pieces of information, they're connected to all of these big players, right? My email is run by a giant company, run by Gmail, and hence by Google and Alphabet Inc. So it's connected to my Google Drive and my Google Docs account and my Google Photos and my Maps, right? It can see where I happen to be right now. It can see the fact that in my emails, I'm going on a flight tomorrow and can recommend me hotels and send me over advertisements and all these fun things, right? Which is, on the one hand, awesome, right? It makes my experience as a user on the internet and as someone that gets to do all of these fun things a lot easier. On the other hand, it's kind of scary how much my chair got stuck, how much the broader internet really can know about you and how much information you really have. And then security is kind of a big one. You have access to some of the most secure technologies and some of the technologies you wouldn't normally have access to. So that's where Web3 comes from, and really the potential benefits of Web3 that I wanted to focus on. And now I think we transition into our second part here, which is blockchain. And one of the questions I have most often gotten when talking about Web3 is, what is the difference between Web3 and blockchain? Because I don't really know. I think I've had this happen a lot of times at events, maybe to first-time hackers or people that are just getting started with Web3 and maybe even finance as a whole. I like to think about it as like all squares are rectangles, but not all rectangles are squares analogy. And that applies really well. Web3 is the rectangle here. Blockchain is a square. What that means is that blockchain is a key technology that enables Web3 to happen. It is not the only part of Web3. There are other parts of Web3 we'll talk about later on in the stream, but it is one of the key players in that realm. It's a Git and GitHub relationship kind of as well. Whereas GitHub is not the only way to interact with Git, but it is kind of a key big player. I would say it's almost all like more of a rectangle square, but Git and GitHub is another good analogy. So a lot of times I've heard these two terms used interchangeably, and most of the time that's correct, because you're pretty much always looking at Web3 technologies that have blockchain in some way, shape, or form. And experts will argue that you can't have Web3 without blockchain. That being said, they're not technically the same thing. And I think that's important to stress, especially when we're talking about history and important things in the Web3 realm. So the next follow-up question I get after that is, okay, so what is Web3 and what is blockchain? Talked a little bit about what Web3 actually is. And blockchain is a key part of Web3, as we've established. But the actual formal definition of blockchain is, and I'm going to read out this thing that I got from, I kid you not, one of my textbooks. It's a decentralized distributed ledger technology that uses immutable transactions to provide security, reliability, and transparency. The chain is made up of blocks, each containing a transaction and a cryptographic hash of the previous block. Now, one of the next things I have is this slide, which is, okay, you just made up a bunch of words and talked to me for like 2 minutes. What does that actually mean? The best analogy I've heard of it is if you've ever done any form of accounting or any form of budgeting, where you write out all of your expenses on one side and what all of your revenue on the other. Blockchain is that, just more technology savvy, really. So decentralized means there's not one key owner, right? That's also kind of what distributed means here. Ledger means it's physically a ledger where you keep track of transactions and expenses and costs and what everyone is spending on what part and where. That uses immutable transactions, which means you can't change them once you've done them, right? You can't go back and say, oh no, actually I only spent $120. Oops, sorry. So what effectively means is that once a transaction is approved, you can't go back and change it. You can obviously make another transaction to revert it, but it's for avoiding cheating and scamming and all of those fun things. To provide security, reliability, and transparency. I think we talked a little bit about that. That's kind of the Web3 benefits of it as well. Kind of the same reasons why Web3 is particularly secure, or the same reasons why blockchain is particularly secure. And the chain is made up of blocks, each containing a transaction and a cryptographic hash of the previous block. So that's where the word blockchain comes from. It is actually a chain of blocks. And I have this next slide here showing the chain of blocks. And I think that is kind of a fun thing to talk about next. We've got another fun person in the chat talking about a simple analogy. Blockchain is a public ledger with cryptographically verifiable line items. Sweet. Now let's talk a little bit about the nitty-gritty technicalities of blockchain. The cool thing about blockchain and ledgers is that they're actually really simple from a technical standpoint. So, you are familiar with data structures. You've probably dabbled in, at the very least, Excel or Google Sheets, right? Done some of the things. Thank goodness, I'm uncomfortable. Done some things maybe in a database. Maybe you've dabbled in XML. They don't have the same metadata and web data as XML files. They don't have keys and relational tables like SQL. They don't have columns and rows like spreadsheets. They really only have account numbers and balances. That's it. Super simple from a data structure perspective, which is kind of a key draw to it from a technical perspective. And what that means is the way that currently most databases work is they're kept on a central server of some form that belongs to somebody. You're probably familiar with AWS or Google Firebase or anything else. The party has the power to determine who has access to various parts of the database, right? They have the ability to alter or delete records, which means that that data is only as trustworthy as the person who actually has access to it. Since the data is also only kept in one place, or at the very least by one person or one group, they also have what is referred to in, I guess, cybersecurity terms as a central point of failure. What that means is that once you gain access to that location, it can fail from that realm. So as a result, actors, courts, criminals, and hackers can all censor, alter, delete, or even deny access to all of these points of data. This is especially bad when we're dealing with finance and financial information, because that's scary. We don't like the fact that bad actors can go ahead and modify and alter and otherwise swap all of these things that we have that are related to our finances. So, in contrast, blockchain and the ledgers are updated and stored by all of these different people all over. They go by different names. Sometimes they're called nodes. Sometimes they're called validators. Sometimes they're called miners. And those transactions are sent to users by these nodes who communicate them to one another via peer-to-peer networks. And so you might be familiar with peer-to-peer networks if you've honestly ever played, funnily enough, if you've ever played video games. A lot of them will have player-to-player interactions across peer-to-peer networks. I think that's honestly one of the reasons why you can play Animal Crossing on my university's Wi-Fi, which is really funny. CSGO is another great one. You couldn't play Animal Crossing with the Switch on my school Wi-Fi. It was very funny. But nodes then examine these sets of candidate transactions that come in from different places, so all of these key players, and they make the decision as a group whether these transactions are valid and make sense or not. So this group of nodes comes to some form of agreement in some way. It's a vote, winner takes all, random draw, rock, paper, scissors, however they decide. And then they use the valid transactions to update the current letter state. In computer science, funnily enough, these are, if you've ever heard of finite state machines or state transition machines, that's really what they are. They're described as finite state machines and state transition machines that use this distributed ledger technology, right? Keep track of changes and flip through different things. Other finite state transition machines are things like traffic lights and elevators. Ooh. Napster. Yes, Napster is such a funny story, actually. For those of you who are not familiar, and it's not very related to Web3 as a whole, but it is a fun CS/technology loophole to dive into if you're ever interested in learning a little bit more about some of the fun history things in the world of tech. Napster is definitely a very fun one to learn a little bit more about, and it kind of honestly changed a lot of the way that we even now interact with music on the internet. So it's a great one. Ooh, I thought ledgers would only record and update one transaction at a time. If this is the diagram on the slide, allowed, I would be worried about conflicts. So the diagram on the slide is very, very oversimplified. In reality, what would happen is these blocks would update, resolve conflicts within before these aspects occurred. So what that would mean is that it would be very difficult for us to really only have one conflict take place at a time, and that would be very grossly inefficient. So yeah, that's kind of, you did a much better job of describing it. The transaction should be atomic. Yep. So you're looking for a way to minimize the amount of times you need to create different blocks. Also from a financial perspective, and also that's something that you would probably do in that discussion stage. So that is kind of the best way to explain it. One of the other key benefits of blockchains, although they reduce the richness and utility of data, at least compared to something like an XML file or a SQL database or even an Excel spreadsheet, the best well-constructed blockchains allow users to interact and exchange things with each other without the need for trust. What that means is that they don't really require super strong beliefs in each other, and also they don't require permission from central authorities, so a big player in some way. Blockchains can create a transaction record that is immutable in the sense that it is really, really impractical from a scientific and computational perspective to change the things that happen. It also allows users to make transactions while maintaining some form of anonymity. So talking through blockchains, let's talk a little bit as to how users will work through this process of wanting to create a new transaction. So this begins with users who submit transactions to nodes, who then distribute them to the rest of the validating network. In general, this means that one node or one player, as we've established earlier, is chosen as the block proposer. So this person is responsible for choosing a group of valid transactions from a long set of unprocessed transactions, building them into this block, and then distributing it to the set of network nodes. So as we discussed earlier, this person will be kind of responsible for making sure that there aren't any conflicts in, at the very least, our very grossly oversimplified version. If all of the nodes agree in some way, shape, or form, or at the very least, the consensus is reached, they add the block at the end of the chain and then use the transaction it contains to update the ledger, kind of going through this. So going on our fun little slide here, we have our account balance and a long list of unprocessed transactions, right? Then one person comes in and is selected as the proposer, which means they look at a long list of transactions, make sure that there aren't conflicts and issues and conflicts and concerns or anything else that people need to deal with, and then create a new and updated account balance. So blockchains are designed to be append only, which effectively means that you can't remove things from blockchains. That means that once a transaction and a block has been added, you can't really delete it. That's part of the reason why it's so hard to update blockchains and why they are considered to be much more capable than databases, or even sets as we know them, right? Because if you think back to maybe your introductory data structures class, or maybe your second data structures class, and if you're not familiar with what I'm talking about, don't worry. But generally, dictionaries, one of the key benefits is that they're very computational to add. They're also very computationally inexpensive to remove, which can be really beneficial from some perspectives, and is one of the reasons why we use different data structures for different things. But it can also be really bad, especially on a finance perspective, right? It's much easier for me to keep track of money and want to add it, but then being able to remove those transactions and remove them from the other realm is honestly not a great thing, right? If I can dabble in people's finances from the back, that's generally not a good thing. Blockchains also go through a cryptographic process called recursive hashing, which I will explain very briefly as the idea that this cryptographic hash for this number that was in the past block is going to be included in the previous block. This creates a recursive hash tree that effectively makes these blockchains for a lot of big words, magic secret number is included in new magic secret number, which means that you can't really change old magic secret number because now there's a new magic secret number, and going all the way back to an older magic secret number is very hard. Now, one of the other ways in which blockchain as a whole, specifically Bitcoin here, which is a key example of blockchain, Bitcoin accounts are numbered. They do not really name an account owner directly, which is one of the reasons why privacy and security is so high up and very important in those. This allows users to make transfers of values without creating direct records of identities of either the sender or the receiver. It is often possible to kind of de-anonymize a user based on the analysis of their transaction traffic. But that would be, kind of difficult to do, but it's one of the reasons why a blockchain, specifically like Bitcoin, is considered to be pseudo-anonymous. So it's the idea of anonymity, but not necessarily always true anonymity. It's kind of, not to, and maybe, I don't know if this is the audience, but kind of how we have Bridgerton, right? And you have the secret gossip lady or gossip girl or anything along those lines, right? They're pseudo-anonymous. The idea is that, someone knows that someone from the community, they can kind of track who's speaking about these things in what way to then try and determine who it really is. But another example of pseudo anonymity here, let's say you transfer your funds from a bank to a crypto exchange like Coinbase. Coinbase and your bank know who you are, since you're required to do know like KYCs or know your customer or know your client or AML on all of their customers. So if you transfer coins within your identity, Coinbase may be required to report that to the IRS because, well, they're required to report something to the IRS. So any transfer out of or into Ethereum is publicly observable and can be associated with you. There are ways to obscure your trail, but machine learning and data analytics are tools that are particularly used for kind of tracking these things more often. This is one of the motivations for many privacy coin projects that have been created using lots of different technologies and other approaches to make it possible. So accounts that are controlled through pairs are usually generated by users. There are public and private key pairs. They're most commonly used in blockchain. Public keys are account numbers. They're kept in the ledger along with a balance. The users create a transaction request, sign it with their private key, which only they have, allowing for nodes, validators, and anyone else to have access to a ledger to verify the signature using data in the publicly recorded transaction that is committed to the block of the chain. To explain it from kind of the tamper-proof part again, let's say I have a block with a block height of 5,000, and I want to change a transaction in block 4,000 for some reason. This would mean that the hash or the secret key of block 4,000 would change, and so the hash in block 4001 would no longer match, which would mean that you would have to redo block 4,000 and block 4001, block 4002, block 4003, so on and so forth, until you got all the way up to block 5,000, which is why the idea of blockchain being tamper-proof comes. All right, awesome. That was a very, very long time of me talking about how blockchain works. The next thing I have planned for our agenda is a quick break from me. So I'm going to be back in right about 10, maybe 15 minutes. At 1, we'll do 1:55 Eastern Daylight. And for that, you'll just get a chance to take a quick break. I'm going to take a quick break. And then at the end, we'll talk. We'll answer the question of how is blockchain tamper-proof, and talk a little bit about finance and financial implications and potentially tons of other helpful things on blockchain. I did not have as much time as I wanted to make slides, so I have a lot less slides for this later part, but that's okay. We'll just talk through it a little bit. So I will see you all in roughly 10 minutes, right at 1:55 EDT, and we'll get to do more fun stuff and more fun streaming. It'll be great. All right, see y'all soon. And we are back. Hello, everybody. Awesome. Okay, cool. Up next, we have my fun little part where I did have a cute little section dedicated to Web3 versus blockchain, and specifically some of the other things, buzzwords that you might have heard around Web3 technologies. So these are dApps, DeFi, and NFTs, or DeFi, DeFi. Not sure how you pronounce it, but that's okay. But generally, thank y'all for answering that question on how blockchain is tamper-proof. Um, generally, all of the very fun things. But dApps or dApps generally just refers to applications run on a blockchain network, not controlled by any central authority. So this is effectively just a decentralized application. So the same way that, an app might be hosted on the internet, the app might be hosted on an AWS server, deployed on Netlify, or run on the iOS App Store or on Google Play, controlled by some central authority in some way, shape, or form. Apps are effectively a way to run these applications on the blockchain instead of on one of these other bigger players. So that's the very, very brief explanation on it. Then DeFi is decentralized finance, very fun little acronym, but it's generally a financial system built on blockchain that allows for people to lend, borrow, or invest money without the need for a bank or another financial institution. And generally, it is the idea that people can interact with each other and their finances on the blockchain without directly involving their bank. So, a good analogy or a good contrast, if you've ever sent any sort of money to your friends or anything through Venmo, Zelle, Cash App, PayPal, paid for anything along those lines, you always need to involve your bank in some way, shape, or form. Generally you need to talk to some other trustworthy financial authority. The idea behind DeFi, or decentralized finance, DeFi, is that you can build out this financial system without needing to involve key players, which on the one hand is really great for private security. On the other hand, can cause issues with, it's especially prone for criminal activity and other illegal activities and illicit activities. So benefits and drawbacks to both. Then we also have NFTs. These are digital assets that are unique, that cannot be replaced. They are used to represent ownership. I think the most important examples of ownership of NFTs are actually like video game tokens and video game currencies or any other online purchases, because you can then send over a non-fungible token. That's what NFT stands for. And the idea behind it is that you can represent ownership of a specific thing in that way. I do want to spend some time talking a little bit about protocols, or specifically the way in which blockchain is verified, and how all of these people, their players, all of those kind of key decision makers are determined for different blockchains. And then I want to spend in our little finance section, which is coming up next. No, oh shoot. Let me swap that over real quick. Technical difficulty, please hold. All right, I will be right back, y'all. Give me just a minute. Okay, friends, we should be good. Perfect. All right, we're good. So going back to what I want to talk about, and that is kind of what proof of work, proof of authority, proof of stake really are. And these are different ways to verify um, kind of consensus in blockchain, specifically kind of make the decision. I'm new to participating in Twitch games and I know how to get regular emojis working. I'm having trouble expressing my enthusiasm. I wish I knew. That is a very valid question. Proof of work blockchains such as Bitcoin and until a while ago Ethereum require that nodes, miners, or key players who help maintain the ledger compete with one another to solve a difficult puzzle for the right to propose the next block in the chain and to receive the rewards and transaction fees as a result. The solution to this puzzle is specific to each block of transaction. The only way to solve it is through brute force, guess and check. It is difficult to solve, but easy to verify that it's correct. The winning block proposer communicates this block to other miners using kind of a gossip network, which means one person communicates to a few people who talk to a few people who talk to a few people, and so on. No central registry or no central way of gathering exists. I'm also going to swap over my technical difficulty base banner because that's not true anymore. But you can announce your presence and connect to a small number of nodes anywhere in the network. Newly mined blocks are then transmitted from one person to another until everyone is aware of them. Users send transaction requests to any node that they happen to know, and count of them then being disseminated to the rest of the network. Once someone receives a new block, they're supposed to verify that the transaction it contains is valid, that the sort of puzzle solution is correct, and then commit that to the version of the blockchain that it keeps. It then stops working on the block it was trying to mine since it can no longer be appended to the previous block. You then choose a new set of transactions, put them into a new block, and start work on kind of getting it set up instead. This is kind of where the cost of proof of work is especially bad, and kind of when you talk about the negative effects being the most unhelpful, this is kind of where it's the most prevalent. All of the work that you put into mining and attempting to be the owner of this block and also attempting to have your transactions be the one that's recognized is wasted. You receive no reward. It is just you and you are sad, and that is all. So that's the unfortunate part of it. Proof of authority is another common part of is another common consensus protocol for blockchain. It's effectively you rotate who is going to propose. They're committed only if they receive approval. You can see how that would be significantly cheaper. It does require a high degree of trust and authority. And then proof of stake blockchains require that nodes participate in validating by putting them in some kind of escrow account or holdover account, like when you put down security deposit. So the share of the votes, as well as the probability that you'll be chosen, is determined by how much money you put into the security deposit account. You circulate the block via a gossip network, like we discussed earlier. If at least a large portion of the weighted vote approves, then the block is committed to the chain. There are endless variations of this used by all sorts of different blockchains. There's a new system used by Ethereum, Honey Badger, and all of these other very, very, well-established and well-known blockchains. They follow the same sort of recursive hashing strategy as the other two approaches that we discussed. If any block is changed, all blocks that follow must be rewritten. Tamper-proof, kind of talking about all of these in here. In the chat, there's tons of questions to tamper-proof specifically that I think are particularly helpful. And then the next thing I want to talk about is our finance section, specifically with smart contracts and kind of the economic impact of blockchain. And the reason why we're going to talk about smart contracts before we talk about the economic and financial impacts of blockchain is because they're honestly is just kind of they're the best or worst example of blockchain going really well or really, really poorly. And so that's why I think it's particularly important to talk about it. So the idea of a smart contract is kind of just a promise, which is digitized. Generally, it's kind of the idea that you're trying to create an experiment of some form. It's supposed to be really smart in the way that you can create like financial accounts. Examples of smart contracts are trying to get rid of things like Coinbase or some other centralized exchange or Binance, for example. So these are an example of blockchains, and then NFTs are also another example of a smart contract. Generally, then that is like kind of ownership in that realm, and then we also get to talk about dApps a little bit more. dApps are effectively a smart contract that can do anything. It's kind of a catch-all term. Then this can include games like, this can include video games, gambling, logistics, chains of custody, kind of anything and everything in between. Decentralized finance is also a big example of a dApp. So whether it's a distributed business process or real estate transactions, anything along those lines. These are very much still at their opening stages, specifically due to the transaction costs involved in blockchains and still being very, very high, and the transaction volume capacity and security potential still being relatively low. So this is kind of the main things that need to happen for the full potential to be realized. So you might be wondering how actually creating a smart contract works, which this is an example for actually answering this question. If I wanted to build a blockchain-based certificate generation validation system, how would you go on? What tech would you use? Kind of walk me through it, high-level picture. For more specific technologies and tools that I would recommend, you can actually go on the Global Hack Week website. They have examples of different challenges that you participate in. They have a great way of describing different Web3 technologies. So for writing on a smart contract, you'd write a computer program in a very high-level language, generally kind of how you would like write an API or create an API or interact with an API. So examples of this can be Viper, Solidity. And then the user will compile the smart contract into very low-level code and then execute a special transaction that deploys it onto the blockchain. We've actually run a really fun workshop a lot of times at MLH, writing out your first smart contract on Stellar with Sorbonne. So I highly, highly recommend that. If you have not familiar with what I'm talking about, you should come out to one of our hackathons. The bytecode, the initial state of any of these variables, are written into a block, so it becomes both immutable and publicly visible. These smart contracts have their own accounts and addresses. They're not controlled by private keys, and anyone can call on them once they've been deployed. When a user wishes to invoke a smart contract, they create a special transaction that calls on the contract functions, includes parameters and other inputs, and authorizes point transfers out of their own account, governed by the rules of the smart contract. The contract is then loaded and executed by the nodes on some form of machine. In the case of Ethereum, is the Ethereum virtual machine. The contracts are then written into a block, which can modify the state of the variables or the balances in lots of different user accounts. People are supposed to verify that each one of these transactions was executed correctly in all of this nodes using that gossip network we talked about earlier. This is kind of where the big issue of using a lot of resources in blockchain comes with as well. An average block is around 25 kilobytes. Storage space for bytecode is pretty scarce. Thousands of nodes have to independently run each smart contract when it is called. The results are communicated to thousands of peers and users. Executing smart contracts uses a great deal of computational power and bandwidth, and running those smart contracts is honestly really, really costly compared to running equivalent code on private web servers. So to align those incentives, smart contract transactions have high transaction fees that are proportional to the amount of storage and computational efforts they require. Smart contracts honestly have a decidedly mixed record. They are one of the leading losses and the most significant points of failure in blockchain. Some of the main examples that are known the most well are DAO, which is from 2016. If you're reading more about those, Parity, Beanstalk, the Nomad Bridge, and the Poly Network Finance Bridge. The next question that we ask ourselves is, why is something so promising in theory, sometimes so disappointing in practice? The big one for blockchain really comes down is human error. Contract creators don't always think of every possible edge case. Sometimes people simply make mistakes, and there's a great incentive for hackers to discover any exploits and those mistakes once a contract starts to carry real financial value. The other example is fraud. In some cases, there's a suspicion that these vulnerabilities are intentional and insiders are responsible for the theft. The next one is a lack of understanding. Smart contracts perform as they are designed to do. Very few users read the code or can verify what the design actually is. And signing a real-world contract when you don't fully understand what you're agreeing to can put you at a lot of risk. Engaging with a smart contract you can't comprehend is really no different. So these factors kind of create a layer of trust in a technology that should really be trustless. And users must trust that a contract was written by very competent and honest people, and the description of the contract functions complete and accurately describes the code. Few, if any, users have the ability to independently verify smart contracts, and those results are honestly really, really evident in the history of failure. So that takes us officially to the end of my slideshow, but I did want to talk a little bit about some of the takeaways of kind of why we had this stream and why I wanted to talk about it, and what you should get from this presentation, and then also leave lots of time. The first one being that, definitely this Web3 is a technology that honestly has a very high degree of potential, and it'll be awesome to see kind of how it develops in future years. But as with anything new, you should always exercise caution, and you should always attempt to do your own research. And while it is supposed to be a trustless technology, in theory and practice, I think right now it's still important to consult some of your trusted sources potentially before you begin diving into doing this research in technology. Make sure you are being a good and thorough digital citizen whenever you are working on anything new, and that you do great research and great work, whatever that work happens to be. The other key important thing I think is that sometimes blockchain gets, and Web3 as a whole gets a lot of negative reputation for whether it's new and complex or sometimes not very, very helpful. And I think that is something that's honestly really, really important for us to consider. It's one of the best ways for us to have a kind of understanding of it. And so I think that's really, really great. And then, yeah, I think that honestly summarizes my thoughts well. Be a good digital citizen, do great things. What I'm going to do is I'm going to call another 10-minute break right now. And what we'll do is after that 10-minute break, that gives you all some time to light out some questions. So we'll be back at 2:25. We'll actually call it 2:30. We'll be back right then. And then what you can do with that is come up with lots of questions. We'll answer them in the chat, and then go through that. And it'll be a great time. And then we'll wrap up the stream whenever we can. But there'll be time for Q&A. So I'm going to go ahead and transition onto, we'll do our big next slide. And I'll be back in just a few minutes. See y'all soon. All right. Hello, hello. I'm going to go ahead and move to our last slide here and then answer some of the questions we're seeing in the chat. First question we have is, what are some fun projects you suggest to make in order to better understand Web3 and blockchain as a beginner with these concepts? I honestly really like the list of potential projects we have on the MLH website under the challenges. Specifically, there is um, a challenge that's learn all about Web3, which I really recommend. Um, that one seems great in terms of beginner friendly concepts and all that. So I really, really recommend that one. If you're also looking to get started, David is running a series of live streams on building a Web3 voting system. And that's one of the challenges that we have as well. We have a marketplace, just building out a Ethereum app, charity donations. All of these are really, really cool. And most of them have really helpful tutorials included. So I highly recommend that. If that's something that you're interested in, definitely look at our Global website. Great. Right. I'm going to go ahead and if a dApp uses a smart contract with a declared bug mistake, first options is partially recovered. Is it a case of having the front end to a new smart contract where the bug was patched and account balance is transferred over? Just guessing, not even sure if that's possible the right way. How could teams individually deploying dApps prevent these issues and how does auditing work? Yeah, so if a dApp uses a smart contract with a discovered bug or a mistake, you definitely are just going to have to likely rerun and redeploy the smart contract, kind of the same way that, in non-centralized Web3 or in centralized Web 2.0 applications, right? You're running patches and bug fixes on one application that you're deploying. Same principles applies here. So you're going to be probably patching over the smart contract, and then that is the best way to fix it. For actually spreading out that information and spreading out that network, you're going to be communicating with the account balances. You're going to be communicating with all of the other users in that gossip network, right? So you're going to be sending information off you interact with, all the other users that you interact with. However, smart contracts are really immutable, so you will have to reach some form of agreement. So ideally, within the smart contract, you'll have a clause to allow for the sort of update and execution of the smart contract in case of a bug issue or any other thing along those lines. If account balances have already been transferred over and you discover the bug elsewhere, the best way to patch it is like in any future smart contract, probably not computationally efficient to patch past contracts. Actually, it's not computationally efficient to patch past contracts, just largely because individuals are going to have a harder time even like hackers are not going to have a benefit exploiting those vulnerabilities as much just because it is so computationally expensive to attempt to modify these things. And so teams and individuals deploying these dApps can really prevent these issues by like doing thorough research before any deployment happens. You want to make sure that you're testing out your smart contracts, you're running them in smaller environments. And you're also, keeping track of instead of leveling that, like, honestly, some degree of trust and ownership that you're interacting with, and the blockchain that you're using. So, at least for the current realms of the technologies, as far as we know them. For auditing, there's not, that's kind of really difficult in the blockchain realm. Like, you can't really audit in the same way that we traditionally audit technologies. You might be able to run some test transactions, run some beta testing and things like that, but it doesn't exactly work the same way that we think of a traditional financial audit. So hopefully that answers your question. It's a good question, and it's one of the key challenges and issues that we're facing in web technology right now. So definitely something to consider. That would be my main recommendation. Yeah. All right, I'm going to go ahead and give people more time to ask questions, probably another 5 or so minutes, and then we'll go ahead and end the stream early. I feel like I've talked for a while. So. Give it a minute or two. Yeah. Thank y'all for asking questions and being interactive by the way. I love it. So yes, you're very, very welcome. Alrighty. Well, it looks like we are almost done. So I'm just gonna go ahead and thank y'all very, very much for watching. Everyone that's a minute or so now. Awesome. Yes. Thank you all for joining me. It was lovely to hang out with you. Lovely to look back at the stream. And I hope to catch you at my stream tomorrow at 10 a.m. Eastern on brainstorming Web3 hackathon ideas. I think it'll be a really fun one. You should come and join me and enjoy the rest of your global hack week and the rest of your day. And I will see you all in the next one. Bye, everybody.